Greetings, was asked to do problem 6, practice problem 6 from lesson 5. So in practice problem 6, that comes from section 5.3, where we're asked to solve exponential equations. We're going to do all of these at this point on the calculator. Once we possess a function known as a logarithm, we'll be able to solve these algebraically, but for the moment we're just going to solve them numerically using the calculator. So the first one here, part A, that's just a function evaluation problem. We simply plug in 5 in for the x. So that's 50 times 1.25 raised to the 5th power. Okay, so go ahead and grab our calculator here. Let me get that. And we're going to put in 50 parentheses 1.25 close parentheses raised to the 5th. And we get the following glorious number, 152.878, blah, blah, blah. Let's just go out. I don't think they told us how many places to go, so we'll go 3 places here, okay? So that's equal to 152.858, excuse me. 58, let's see, is that 7? No, we're going to 588. Okay, cool. All right, I'll let you do part B. It's the same thing. You're just going to come in and evaluate 50 times 1.25 raised to the 50th, and it's pretty likely you're going to maybe start running into scientific notation. Actually, let's go ahead and do it. Why not? Because I can just hit second enter here, and I can edit the last thing I did, which is such a beautiful thing, and make that a 50. Oh, doesn't go into scientific notation yet. Great. So that's what, 350, that's 3,503,246.161. Okay, cool. I'll let you finish that up on your own. Let's come down here and take a look at C and D. Those are the ones that were actually causing people trouble with C and D. So how do we go about solving these? Well, what we need to do is realize that first of all, this time they say find x when f of x is equal to this. So in other words, they gave us the y value, they want the x value. In the previous two problems, they gave us x. In other words, they told us here x was equal to 5, y was equal to what? Okay, down here, what they're saying is x is equal to what when y is equal to 75. Okay, so what that means is we have to solve the following equation. We have to solve 75 is equal to 50 times 1.25 raised to the x power. So at the moment we do not possess the algebraic technique necessary to solve that, but no big deal because we can totally solve that numerically if we're just looking for a decimal approximation, not the exact solution, using our calculator. So let's go back to the calculator here. And what we're going to have to do is enter into our calculator the left-hand side and the right-hand side. So I've put the 50 times 1.25 raised to the x into y1, and I put the 75 into y2. Now, there is a fair amount of work in the lesson trying to show you how to get your window settings, but I know it's an increasing exponential function. I know looking at my base is bigger than 1. I know that this thing's going to take off, excuse me, and it's going to hopefully pass through 75 on its way up. So that's why we know that there is a point of intersection here, and we know that I'm going to have to set my window so that I at least get up to 75. So what I did is I went from negative 10 to 10 on the x and from negative 10 to 100 on the y, recognizing that y2 equal to 75 is going to be the horizontal line going through 75, and set an x scale equal to 10. So once I do that and I press graph, I get the following graph. All right, now the show all your works part is that you want to make me a sketch of that on your homework. So whenever you're using the calculator to solve graphically, it is a requirement that you come in and give an accurate sketch of what you see on the calculator screen. So a couple of things that would be useful there would be to put the x and the y here and to put your window settings on your graph. Very important to put the window settings on so that I know how to reproduce the graph that you just made. So if I want to look at it, I can do that too, okay? So now what I'm looking for, what I want to know is that point of intersection right there. And that point of intersection right there is going to give me the corresponding x value that I need that solves this equation. It'll give me the y value too, but I'm not necessarily interested in that. I know the y value is 75, excuse me. But what I need to know is what is the x value. So let's go into the calculator again. And to get to that intersection routine, you're going to hit second, trace to get into the calc menu, and then you'll see option number 5 is intersect, and then you go first curve, second curve, best guess, and it comes up with an x value here of approximately, let's go back for just a second here, 1.8171. So if we go out 4 places, which you don't have to, I'm just getting totally anal. If you went 1.817, that's perfect. That'd be just fine, okay? So hopefully that makes sense how we got that solution. Review the lesson if you need some more help. There's lots of really good stuff in the lesson about this. Okay, let's go take a look at part D. So in part D, again, they're saying what is x equal to when y is equal to negative 25. All right, so let's go ahead and put those into y1 and y2 respectfully. Those being, let me back up for just a moment here, those being negative 25 is equal to 50 times 1.25 to the x. Okay, so some of you may be going, no, stop, Mike. You know what's going to happen, but now I'm going to do it anyway. I'm going for it. So I don't have to change y1 because that's still the same function, but down here we got to put in negative 25. So now notice my current window settings aren't going to do me any good. I need to reset the window here so that I can actually see the, whether or not these graphs intersect each other. This time I need to have my y min go down to, let's say, negative 30. There's just got to be less than negative 25, so I see that horizontal line, y equals negative 25. And let's set the x max back to 10, and we can set the scale here to 5. Okay. Right now, if I press graph, there's my exponential. I don't see much of it, but that's okay. And there's y2, which I see is what I need to see. In fact, here, let's go in, let's grab a little bit more of y max. That was probably a mistake getting rid of that 100 in there. Let's leave that in. That's okay. This is just demonstrating that sometimes you have to kind of guess and check with the window settings. You don't necessarily get them on your first try. Okay, that's going to be actually a better window. Let's do that. And what we see is what I knew all along before we even started, is that these two graphs do not intersect each other. Part of the reason you know that is you got to remember that the x-axis is playing the starring role of a horizontal asymptote here. And so this function is coming up from negative infinity and never crossing the x-axis, and yet this horizontal line is below the x-axis. Therefore, we know there is no point of intersection here, and so that we know that there is no solution. Or you could write does not exist for the, I know some folks have been asking me, can you put D and E? And yeah, D and E works, that's fine. But you do need to give me a sketch of the situation here so that we know what happened, okay? So we know we've got that function, which is our y equals to 50 times 1.25 raised to the x, and we've got this function, which is our y equals negative 25, and we see that there is no point of intersection, therefore there is no solution. Okay, so a couple other things just to gussy these up a little bit. It wouldn't hurt, to make, particularly in this problem, to help with our comprehension of this, to draw in the horizontal asymptote with a dashed line, to remind ourselves of that. And another thing that wouldn't hurt either would be to give ourselves where it crosses the y-axis. I know it's crossing the y-axis here at 0.50. When I'm talking about crossing the y-axis, of course, I'm referring to this function right here, our f of x equal to 50 times 1.25 to the x. And of course, same thing over here. It didn't change. That's still 0 by 50. All right, hopefully that helps. If not, please feel free to post me another message and I'll take another go at it.